Good evening, everyone. Today in this lecture, we'll be discussing about motion in two dimensions. In the last lecture, we finished motion along a straight line, but today in this lecture, we'll be starting with the motion in two dimensions. And in motion in two dimensions, one of the two-dimensional motion that's important is projectile motion, right? Projectile motion. And we know that projectile motion is that suppose any body which is falling or moving under the gravity, force of gravity only, we call that body as a projectile, right? So in the projectile motion, we'll be mainly discussing about the two projectiles. One projectile we call as uh, oblique projectile, and another projectile will be nothing. It will be called as horizontal projectile, right? So we have generally two types of projectiles. One is oblique projectile, and another is horizontal projectile, right? Horizontal projectile. So we'll be first discussing about the oblique projectile. So in case of oblique projectile, what we do is that suppose we are projecting a projectile, right? We're projecting a projectile at an angle of theta with respect to the horizontal, right? So this is our projectile, and we are projecting it at an angle of theta with respect to horizontal with initial speed u. This is initial speed u, and this is our y-axis, and this is our x-axis, right? And the origin of this xy plane is the reference point for this projectile. And we know that velocity is a vector. We can resolve this initial velocity into two components. One component will be along x, another component will be along y. So the component along x direction will be the u cos of theta, right? And the component along y direction will be u sin theta. So in this projectile, we have to calculate different parameters of this projectile, right? The maximum horizontal distance of this projectile is from this origin O to this point where it strikes. Let me call this point as P. So this maximum horizontal between O to P, maximum horizontal distance, we call this as the range of projectile, right? This is nothing, this is range of projectile. This is the range of projectile, right? The time taken by this projectile to hit on the same horizontal level, we call this as time of flight. So time of flight is nothing. It's the time taken by this projectile to hit back on the same horizontal level. We call this as the time of flight of projectile, right? And the maximum height attained by this projectile, that's what we call as h max or maximum height. So mainly we have to calculate the three parameters for this oblique projectile, which has been projected at an angle of theta with the horizontal. One is the range of the projectile. What is the range of this projectile? It means that what is the maximum horizontal distance that this projectile can cover when it's projected with initial speed u at an angle of theta with the horizontal. And number 2 point is we have to calculate the maximum height. The maximum height that this projectile can go when it's projected at an angle of theta and initial speed or initial velocity u, right? And the time taken by this projectile to hit back on the same horizontal level, we call that as time of flight. So we have to calculate all these three parameters. And the fourth important parameter is the equation of trajectory for this projectile. And the equation of trajectory is nothing. That's the relation between x coordinate and y coordinate of this projectile at any time t, right? So we'll be proceeding one by one for all these parameters, right? And we know that this is the projectile under gravity, right? And we know that this projectile is moving only under gravity, right? The only force is here is due to gravity, right? Due to gravity only. The only force acting on this projectile is the gravitational force. And that gravitational force is directed vertically downwards towards the center of the earth, and that's equal to mg. Or we can say that acceleration due to gravity here is nothing, it's equal to g, and minus g we can say because it's vertically downwards. We'll be using all the sign conventions. Any measurement done above the origin will be taken as positive, and any measurement done below the origin will be taken as negative, right? So we know that equations of motion are valid here because acceleration here is constant, right? Acceleration is a constant here. If the acceleration is constant, it means that we can use the equations of motion, right? And one more important point is that both the components of the projectile, horizontal component as well as the vertical component of projectile, these are two independent components, right? So these components of the projectile are independent to each other. We can apply the equation of motion separately along y and the separately along x direction, right? So it means that we can rewrite the equations of motion like this, that Vy should be equal to Uy plus A by T, right? Comma, Y should be equal to Uyt plus half A by T square, right? Similarly, X should be equal to Ux plus Axt, right? Or X will be equal to Uxt plus half Axt square, right? And one more equation we can use is Vy square should be equal to Uy square plus 2Ay into y, right? And Px square should be equal to Ux square plus twice Ax into x, right? So where Vx is the horizontal component of the velocity at any time interval t, right? At any time t, and Vy is the vertical component of the velocity at any time t. And one of the important points here is there is no component of acceleration along the x direction. It means that Ax is 0. If Ax is 0, it means that Ux or Vx should be a constant, right? Vx should be a constant. It means that horizontal component of the velocity will be always equal to initial horizontal component of the velocity, that will be equal to u cos theta. So this component of the velocity is never going to change because there is no component of the acceleration along x direction, right? So if we say at the topmost point, the particle or the projectile is moving in the horizontal direction. So at topmost point, the only velocity for this projectile will be equal to u cos theta, right? And the vertical component at the topmost point of this projectile will be equal to 0, right? So let's try to calculate the time of flight for this projectile motion first. And for time of flight, we can see that when the particle strikes back to the point P, it means that the vertical component or the vertical displacement will be 0, right? At point P, vertical component of the displacement will be equal to 0. It means that when time is equal to time of flight, right, the vertical component of the displacement vector will be equal to 0, right? So when the particle strikes back on the same horizontal surface, the vertical component of the displacement of the projectile has to be equal to 0, correct? So it means that we can use this equation, y is equal to Uit plus half Ay t square, right? And we know that the only acceleration along y direction, that's acceleration due to gravity, that's equal to minus g because it's vertically downwards. And when the particle strikes back at point P, y is equal to 0, right? And then time is equal to time of flight, right? So substituting or plugging all these values of ay, y, or t, we can put y equal to 0, and uy is the vertical component of the velocity, initial velocity. So that's u sine theta here. And the t is the time of flight. So it will be minus half gt square, right? So it will be equal to minus half gt square. It means that our u sine theta u sine theta t will be equal to half gt square, right? So this t and t will get cancelled. So from here, our t will be nothing. It will be equal to 2u sine theta over g. So this is nothing. This is the time of flight for the projectile, right? So this is the time of flight of this projectile. This is the time taken by this projectile to strike back on the same horizontal level, right? So time of flight here, we can see clearly depends upon two factors mainly here. One is the initial velocity with which it has been projected, and another is the theta. That's the angle which this projectile initially makes with the horizontal line of xy plane, right? So theta is the angle with which it has been projected vertically, right? Sorry, obliquely. So time of flight depends upon two factors. One is u, another is theta, right? So we can rewrite it as also u sine theta is our vertical component. We can rewrite it as 2ui upon g. So this is also another representation of the time of flight, right? So this is our time of flight, right? And that maximum horizontal distance, we can see here, this is the maximum horizontal distance traveled by this projectile during this time of flight, what we call as the range of projectile, right? The maximum horizontal distance of this projectile will be equal to the range of the projectile, right? So at that time, the time will be equal to the time of flight, right? That will be equal to the time of flight. It means that we can write this equation. X is equal to X will be equal to ux t plus half ax t square, right? And one more important point is that there is no component of the acceleration along x. Ax is 0. And when it strikes back, the t equal to time of flight, that's the capital T. It means that, and x is nothing, it's r. That's the range of projectile, right? The range of projectile. So it means that we can substitute the value of x and t in the above equation. So x will be replaced with r, and x is 0, so it will be ux into t, right? So ux is nothing, it's u cos of theta, and time of flight we calculated is 2u sine theta over g. So this will be 2u sine theta over g. So from here we can see that our time of flight is 2u square sine theta cos theta over g, right? So this is our range. We can rewrite or simplify this equation like, we know that 2 sine theta cos theta is equal to 1. 2 sine theta cos theta is equal to sine 2 theta. This is the trigonometric equation that we can use. 2i sine theta cos theta, we can substitute it as sine 2 theta. So replacing the value of 2 sine theta cos theta with the sine 2 theta, we get range as u square sine 2 theta over g, right? So this is the range of this projectile, right? This is the equation for calculating the range of the projectile, right? So range is equal to u square sine 2 theta over g, correct? So once again, our range depends on the two factors. One factor is the initial speed with which it has been projected. Another factor is the angle with which it has been projected with respect to the horizontal, right? Now let's try to see, suppose that if we project a projectile at different angles, right? We project a projectile at different angles, but with same speed, right? Suppose we're projecting a projectile like this, and like this. You can see that for different angles, let me call this as theta 1, and then this will be theta 2, and this will be theta 3, right? So we can see that for different angles of projection, but the initial speed is u in all the three cases, right? The range of this projectile is different, right? So it means that we can have different range for the projectile if the angle of projections are different, and we're here to see for which angle the range of this projectile can be maximum, right? For which angle, at which angle we should project this projectile so as to get the maximum range, right? Which means that for maximum range, for maximum range, for maximum range of projectile, we know that r is nothing, it's equal to u square sine 2 theta over g, and u is same for all the projections, right? For all the three projections, u is a constant, so initial speed is constant. We are just varying the theta. We're just changing the theta with respect to the horizontal. It means that the maximum range now will depend upon the theta only, and the range will be maximum only. Range will be maximum only when this part, that's sine 2 theta part, if this is maximum, if this is maximum, then range of the projectile will be a maximum, right? It means that for range to be maximum, for range to be maximum, sine 2 theta should be maximum, right? So for range to be maximum, sine 2 theta should be a maximum, right? And we know that the maximum value of sine 2 theta is 1. If we talk about the range of this sine of 2 theta, the range of this sine of 2 theta is nothing. Sine of 2 theta will lie between, it will lie between -1 and +1, right? So the minimum value of this sine 2 theta is -1 and the maximum value of this sine 2 theta is +1. So we can have maximum value of the range when the sine 2 theta is the maximum value. And we know that the sine theta is the maximum value equal to +1. So it means that sine 2 theta should be equal to +1 for the range to be maximum. And we know that sine theta has maximum value at, that is sine 90 degree, right? So it means that sine 2 theta should be equal to sine 90, or we can say that 2 theta should be equal to 90 degree, right? Which implies that our theta is nothing, that's 90 over 2, that's equal to 45 degree. It means that the maximum range of the projectile is only possible when we project a projectile at an angle of 45 degree with the horizontal, then we are going to get the maximum range for the projectile, right? So for the projectile, the range will be maximum for an angle of 45 degree, right? So at an angle of 45 degree, the range of this projectile is going to be maximum. And one more point is that, suppose that our range is nothing, that's equal to u square 2u square sine theta cos theta over g, right? Twice u square sine theta cos theta over g. Let's suppose that we have projectile. We're projecting a projectile at two different angles, right? Suppose that we're initially projecting a projectile at an angle of theta, right? At an angle of theta, we're projecting this projectile. So this is angle theta, and we can also project this projectile at an angle of 90 minus theta, right? So this is the angle. Let me call this as 90 minus theta. And let's see, let me call this as R1 and let me call this as R2. Let's see what will be the range of these two projectiles at an angle of theta and 90 minus theta, right? So at an angle of theta, the range of the projectile will be equal to, R is equal to 2u square sine of theta cos theta over g, right? Now let me call this as R1. Now at theta equal to 90 minus theta, right? Then R2 will be equal to 2u square sine of 90 minus theta, right? And cos of 90 minus theta over g, right? Over g. And we know that sine 90 minus theta is nothing, it's cos theta. And cos 90 minus theta, it's equal to sine theta, right? So we can replace it with this. We'll be left with 2u square sine theta 2u square cos theta sine theta over g, right? It means that from, let me call this as first and this is second, right? And we can clearly see that the RHS of the first equation and the second equation is same. It means that R1 must be equal to R2, right? It means that the conclusion is that if we project a projectile at an angle of theta or 90 minus theta, if a projectile is projected at an angle of theta or 90 minus theta, then the range of the projectile is going to be same, right? Therefore, range of projectile at theta and 90 minus theta will be same, right? So the range of projectile at theta and 90 minus theta will be same. So the range of the projectile is not going to be changed, right? So R1 will be equal to R2 in that case. So we have calculated two quantities here. One is the range of the projectile, right? And another is the time of flight of the projectile, right? Let's suppose if this projectile has been projected, if this projectile is projected vertically upwards, right? If we project a body vertically upwards like this, vertically upwards, it means the angle it makes with the horizontal is 90 degree, right? The angle it makes with the horizontal is 90 degree. In that case, the theta will be 90 degree. It means that we can just put the value of r here. That will be equal to u square sine 2 theta over g. Our theta here is 90 degree, right? Then our sine of 2 theta will be equal to 180 degree, right? Correct? Sine of 2 theta will be equal to sine of 180 degree, right? Sine of 2 theta will be equal to sine of 180 degree, right? And sine of 180 degree is nothing, it's equal to 0. If this is 0, it means that the range of this projectile is equal to 0. It means that whenever a projectile, any body vertically upwards, right, at an angle of 90 degree with the horizontal displacement of the projectile when it falls back on the same horizontal line is going to be 0, right? So the range of this projectile will be equal to 0, right? So what happens is that this projectile will just move vertically upwards. This projectile will just move vertically upwards and come back and strike back on the horizontal level, right? So that the horizontal displacement or the horizontal change in the x will be equal to 0. Or we can say the range of projectile is equal to 0, right? Let's move on to the next part of this topic. The next part is that we have to calculate the maximum height, right? Maximum height of projectile, right? Maximum height, right? So it means that let's suppose that this is the projectile here. So this is the projectile. And the maximum height is the maximum vertical displacement of this projectile. So this will be the maximum height, right? So this will be the maximum height. Let me call this as h max. And we know that at maximum height, The only component of the speed is the horizontal component, that's Vx, and it is always constant for a projectile, that's u cos theta, right? That's u cos theta, and it has been projected at an angle of theta, right? If the only component at maximum height is u cos theta, it means that the vertical component of this projectile has to be equal to 0, right? The vertical component of this projectile has to be equal to 0, and the horizontal initial component of this projectile is u cos theta, and the initial horizontal component of this projectile or the vertical component of this projectile is u sin theta, right? So uy is nothing that's equal to u sin theta, right? That's the initial vertical component for this projectile. And when the projectile is at maximum height, the vertical component of the projectile, velocity of the projectile becomes 0, right? So we can write here at h max, Vy becomes 0, right? At h max, Vy becomes 0. So it means that we can use this equation, Vy square is equal to Uy square plus 2Ay, right? And the maximum height attained by this projectile is h. Let me call this as h max, right? And Ay is nothing that's equal to minus g, correct? And Vy is equal to 0, right? Vy is equal to 0. So 0 is equal to Uy square minus 2g h max. From here, we can conclude that our h max, or the maximum height attained by this projectile, is nothing that's Uy square upon 2g, right? Or we can rewrite it as, substituting the value of Uy as u sin theta, it will be u square sin square theta over 2g, right? So the maximum height attained by this projectile is nothing that's equal to u square sin square theta over 2g. Once again, this maximum height depends upon the two factors. One is the initial speed of this projectile with which it has been projected, and theta. Theta is the angle with the horizontal, right? With the horizontal. So let's calculate h max when range of projectile is maximum, right? Range of projectile is maximum. And we know that range of projectile is maximum at theta equal to 45 degree, right? If the theta is equal to 45 degree, it means that the maximum height attained by this projectile will be h max, that will be equal to u square sin square 45 degree upon 2g, right? So sin 45 is 1 over root 2. So it will be 1 over root 2 whole square upon 2g, right? So that will be equal to u square upon 4g. So it means that when the range is maximum, or projectile has been projected at an angle of 45 degree, then the maximum height attained by this projectile will be equal to u square upon 4g, right? U square upon 4g. So that's how we calculate the maximum height of a projectile. And one more important point with respect to this projectile motion is that there are two important assumptions that this projectile motion is based upon, right? One important assumption is that there is no frictional force, there is no air drag present in the atmosphere. We neglect the air drag or the friction due to atmosphere or friction due to the air, right? Otherwise, the results will be quite different than this that we are calculating here, right? And another important point is that we're assuming that the height of this projectile is very small, right? If the height of projectile is not small, then the value of the acceleration due to gravity is going to change. And when the value of acceleration due to gravity is going to change, and that time we cannot use the equations of a motion because the acceleration will not be a constant then, and the situation or the solution for that projectile is going to be altogether a different solution, right? So there are two important assumptions that this projectile is based upon. One is there is no friction there is no friction. So it means that friction due to air is neglected, right? And G is assumed to be constant. G is assumed to be a constant, right? So these are the two important assumptions, and G will be only assumed to be or considered to be constant if the height of this projectile is very small. Like height of this projectile can be 10 meters, 15 meters, 20 meters, 30 meters, right? The height of this projectile cannot be 5 kilometers, 10 kilometers, 20 kilometers. Then what is going to happen? Then acceleration due to gravity will not be a constant then, and we cannot use the equations of motion at that time. So the solution for the projectile at the moment will be altogether a different solution, right? We will not be using the equations of motion at that time, right? So these are two important assumptions that this projectile motion or that this calculation for the projectile motion is based upon, right? So let's move on to the final calculation with respect to the projectile motion, oblique projectile, right? That's nothing, that's the trajectory projectile, right? Trajectory of a projectile. The trajectory of a projectile or any particle is actually the path which the particle follows, right? Trajectory is nothing, it's the path followed by a body, right? Trajectory is path followed by a body, right? The trajectory is nothing, path followed by a body, right? So trajectory can be a straight line if the path followed by a body is straight line, right? The trajectory can be elliptical, the trajectory can be circular, the trajectory can be hyperbolic as well, right? Sorry, parabolic as well. So this is the parabolic trajectory, right? So trajectory is nothing, it's the path followed by a body, right? Path followed by a particle. And similarly, here we have to calculate what is the path or the equation that defines the path of this body, that shows the path of this body is actually a parabolic, right? So the path for this body is a parabolic path, right? We have to prove that, we have to show that actually this is a parabola, right? So we'll be calculating the trajectory of a projectile. And by trajectory, we mean that we have to establish a relation between the coordinates of a particle, right? Eliminating all other variables, right? There will be a variable time also involved. So we'll try to eliminate the time variable here and try to establish a relation between x coordinate and y coordinate of this projectile, right? So that will be the trajectory of this equation of trajectory for this projectile, right? We know that position at any time t, horizontal position or x coordinate of this projectile at any time t is nothing, that's given by uxt plus half axt square, right? Where our ax is nothing, ax is equal to 0, so this term will vanish. So we'll be left with our x will be nothing, it will be equal to u cos theta t, right? Or we can write t here as x upon u cos theta, right? X upon u cos theta. And similarly, our y is nothing, that's equal to uy square, y is equal to uyt plus half ayt square, right? So we know that t is equal to x upon u cos theta. We can plug this value of t in this equation. We get y is equal to, so uy is our u sin theta, right? And our t here is x upon u cos theta. And ay, we know that ay is the acceleration due to gravity, that's equal to minus g, right? That's minus g upon t, minus g upon 2. and t square will be x square upon u square cos square theta, right? From here, u and u will get cancelled. We'll get y as sin theta over cos theta will be tan theta. We can write it as x tan theta, right? X tan theta minus gx square 2u square cos square theta, right? Or we can rewrite it as y is equal to ax minus beta x square, right? Ax minus beta x square, where our a is a constant that's equal to tan of theta, and our beta is equal to g upon 2u square cos square theta, right? 2u square cos square theta. So from here we can see that now this is a quadratic equation in x, right? And this represents a parabola, and it particularly represents a downward parabola, right? Downward parabola, right? So that's the reason when we practically see a projectile motion, when we practically see a projectile, its trajectory is always a downward parabola, right? So this is the equation established between x and y coordinate of the projectile, and this projectile says us that the trajectory of this projectile is going to be parabolic, right? So that's how we represent the equation of parabola for this projectile, right? So we're done with the equation of trajectory for this projectile motion. We are also done with the maximum height, time of flight, and range of this projectile. In the next class, we'll be discussing about the horizontal projectile, right? When the projectile will be projected at some height and at an angle of 0 degree with the horizontal, then we'll also try to calculate all these parameters for the horizontal projectile as well. So that's it for today. We'll be meeting in the next class and we'll discuss the horizontal projectile, right? So take care.